do it.
Okay, it doesn't matter, but here's the problem. All three of these tails are touching. You can't do that.
It's got to be nose to tail.
It's got to be nose to tail. So this tail has to go to somebody's nose. So pick somebody's nose for him to go to. If you're wanting to leave this guy still, then
So then you're gonna have to at least move him over here or something.
you're going to either have to take this guy and move it down to this guy's nose, or take this guy and move it down to this guy's nose. One of the two. Pick one. Any one works.
So if we take this one down,
If you take that one down,
Wait a minute, use a different color.
we're gonna
okay.
use that angle.
Now watch. You just leave
It's
that
what
there.
angle is where I get a little bit.
The angle doesn't change. You can't change angle. You're changing the
You're
problem.
parallel, see?
Okay.
Now there's
You're just
that.
bringing it straight
Right
down.
now.
You
Okay.
can't
Now
change
your
the
nose
angle.
to tail.
So then the angle's gonna be the same that it was.
Everything's the
Everything's
same.
the same.
Now,
And
what about
how
this
do you
one?
move?
Okay, so we've taken care of this guy, so he's off the screen.
No,
now.
no, leave him there.
All
Okay,
right.
We'll
leave
just
him
do
there
that
for
and
now.
do it. This is
A
now
different
red.
color.
Okay, now you got this guy. We got two tails touching here. That doesn't work. It's
Right.
got to be nose to tail. Well, there's only one nose left. That nose is taken up. This is the only nose
Right.
left. So his tail has to go to that nose, and his nose has to go to that tail because it's the only
And
tail left.
he's gonna stay on the same angle.
He's going to stay on the same angle. You can't change the angle because you're basically saying
That's great stuff, though.
You're saying
Oh, I just was amazed at it. Absolutely amazed.
you're saying Susie's.
Thank you.
You're saying Susie's pulling that way, right? Well,
Right.
if you change the angle of that arrow, Susie ain't pulling that way anymore. You know, she's pulling that way. That ain't right.
Huh.
She's got to keep pulling the same way.
That is excellent. Because that's where I was having trouble making sure I had the right angle in it.
Mm-hmm.
Because I looked at the back bow, had the wrong answer, so I just changed the angle and it was fine.
Mm-hmm.
You know.
I'm done.
Giving this is 20 pounds, right?
Right.
So you're giving that, okay?
And you want to know these two.
And you're probably going to
Yeah,
be given this angle
some kind
here,
of angle.
right? You know, 30 degrees or something. And you're going to be given this angle here. It's like 35 degrees, right?
Right.
Okay? So, this is where it's a little bit tricky, okay? Since you brought this guy down here,
So
okay?
he's now underneath.
He's now underneath, and
Gotcha.
you know that's 35
That,
degrees
oh, that's
there,
so much nicer.
right?
Yeah.
And you know from your freaking trig that that's also 35, right?
Right.
Okay? You're trying to figure out this angle ultimately, okay? Well, this guy came from here, and you know that between here and here was 30 degrees, so that's that same angle right there. That's 30
30.
degrees.
You love it, man.
So this is actually 65 degrees
Yep.
here,
All
all
together.
right?
And you
Yeah.
know that one because you got 35 on the outside.
What?
It's a right angle.
Oh, right. Okay, so this is 55, right?
The other one's simple.
And so now 55 and 65 subtracted from 180,
And
Gives
got
you this
that
angle.
other angle.
right?
Love it.
So it's 60, that's 120, so this is 60, right?
I'll be practicing
Okay.
that this weekend.
I'm telling you.
That's excellent.
So now what do you have? You've got this triangle, okay? You know all three angles.
I want a picture of this when he's done.
You got it.
You got a triangle, you know all three angles. The big key is you need to know some angle and some side somewhere. Both. Like the angle and the side across from it.
And one
Somewhere.
side, yeah.
One of
So
them.
we're going to use law of signs.
We use the law of signs, which I've always hated until
but
this
it's so
class.
easy.
Until this class. I've never used that. I'd always go some other way. So now you just do
This is this and da-da-da.
25 over sine.
Right.
65 is that's your thing you use for each part of the problem. You keep using this over and over again, and you just set that equal to whatever you're trying to find. So like say this is P and this is Q, then you just put P over sine, whatever angles across from
60.
P, 60. If he wants you to do Q, you do the same thing, Q over sine 55 equals 20 over sine 65, and it's just so easy.
Oh, it is. I mean, when he
I
showed
like
me
the
last
way he
night.
moved because he didn't show us that.
Oh, he didn't?
He didn't.
He moved mine last night. He
It
took
like
that
that.
and came here, and he said, now watch, if you don't like that, we can go here. And then he showed me why, it's because it's just hooking them up.
Mm-hmm.
And once you catch that idea, you go, wow, now that's neat. That's neat.
But so he showed me a third way of doing them, and he doesn't just do triangles.
Really?
Oh, he
No.
does.
If you end up with a whole bunch of
Four forces.
forces, you can have 4, 5, 10 going all sorts of different directions and stuff, you know, right?
Yeah, he did one with 4 for me last night.
Right. Well,
Hooking 'em up.
they hook together into a polygon of some sort, depending on how many of them you got. You know, and they can even start going this way and stuff like that.
Wow, that's pretty cool.
It
You
is.
know, and then your answer is always going to be connecting that last tail to that last nose. That's your answer. And he's real big on drawing stuff to scale and getting a ruler out and measuring that.
Oh, he is.
And you can write that answer down.
Oh.
You can't even figure the math out on it, but if you can draw it to scale and measure it, you know, he'll let
So
you.
you're in there for 3 hours just working problems, basically.
Mhm.
The guys, there's 3, he only had 3 in the sprint. And every time I go by the window, they'd all be scattered around the room working on problems. And I always thought, why don't they put them together? But this guy had them all over the room, all by themselves.
Well, we were allowed to work together last night.
Yeah, last night he let us work together, but nobody really did. Everybody was pretty quiet to themselves and working on stuff. But he showed me a third way to do this last night. Okay, so now you got the sines and cosines way to do it. You can put these things together into triangles and stuff. The way he showed me last night is that he keeps saying all the forces have to act through the same point.
Yep, and he was on that too.
So, like this one, that's obvious. They're already drawn working through the same point, you know? But sometimes you got a problem, like we was doing that one problem that's a log or something, you know, and it weighs, you know, 100 pounds or something, I don't know. And got a guy with a rope on it, pulling,
Yep.
you know, and what else did he want? I think it was pretty much it. But anyway, so you've got this arrow here, you got this guy pulling here, and so you know that's acting at this point, and that's acting at this point. You got some other forces in the paper and everything. Well, he ends up, you know, and here's the pivot down here on the ground, right? So that's where one of the forces is and stuff, you know. Well, he ends up saying, well, all the forces have to act through the same point. So he says, because of that, you can take this and put it up there, and then you just draw a line between here, you know, and that's the direction that force is acting through, because it's got to act through the same point and stuff.
Right.
And so that this one's actually not acting like that, it's acting
Right there.
like that, you know. And so
Wow.
this is,
Right.
That trips your head.
Oh, when he
Yeah,
first
I'm still a
started,
little
I mean, he
tripped
did
out
all this
sometimes
stuff
when he's
like in
moving
10
around.
minutes last night, went through 3 or 4 different things, quick.
Yeah, he moves
And I
fast.
wanted to go, can I come back? Can I come back? I want to see it again.
Who's this guy?
Johansson?
Yeah, Niles Johansson.